Hello world, good morning, good afternoon, good evening. Welcome to RoboThought Zero to Hero series. C++ coding in Arduino Mega, Arduino UNO, Arduino Nano, any series of Arduino you can learn C++ coding. So we are on lesson number 43 and I am going to talk about, make you to understand about potentiometer. All right, so in this lesson I will explain about variable resistance, which is also known as a potentiometer, or in short you can call it as pot. All right, the potentiometer is a device something like this, guys. It's pretty sleek and neat and with three different pins. So it's basically it's a kind of sensor device which is used to measure the voltage or electrical potential. All right, it provides a variable resistance when you rotate like this, when the shaft of this particular device is turned left or right like this, right? So the resistance will change within the tracks inside. So here we will, in this particular lesson, we will try to measure the amount of resistance as an analog value produced by the potentiometer. All right. So hope you understand how this logic works. Basically, we will connect the potentiometer to the Arduino UNO board, and then we will measure the state of the potentiometer from one of the analog pins. The required code, of course, will be, we need to do some coding and to read the information which is coming out, right? So the variable resistance which is measured by the potentiometer can be easily read as an analog value into the Arduino board. So the way it looks like, let me show it to you. So this is the way we will be connecting. This is the basic diagram. So for example, in pin number, the middle pin, the center pin, which is mentioned as out, right? In some potentiometer it will be mentioned as output pin, some of the potentiometer it will be mentioned as data, DATA, right? Only that pin has to be connected to any of the analog pins of Arduino. So here in this drawing I am showing it as if it is connected to A2, which is one of the analog pin. And of course there's a ground and VCC pin, the left hand side. The ground will go to ground and the VCC will pin go to your 5 volt. All right, so that's the way it works. So basically how this entire operations works, guys. So the middle terminal of the potentiometer is connected to analog pin to read the analog data. Okay, it reads the information from that particular pin. And the potentiometer is basically a 3-terminal device. There are also 4 and 5 terminals, which is at a later stage, maybe if it is required I'll cover that particular lesson. Inside the potentiometer, basically there is a rotating contact, okay, that acts as an adjustable voltage divider. All right, the potentiometer structure consists of a sliding contact called as a wiper. Okay, the wiper, a resistive, it's basically a resistive element, and the electrical terminals and the housing, proper housing on top like this. There's electrical terminal and then there is a sliding contact inside, okay, like this, which is called a wiper. And the sliding contact moves along the resistive element while the housing consists of the wiper and the element itself. So the fixed input voltage is applied across the two ends of the terminal of a potentiometer, which further produces the adjustable output voltage at the wiper or the slider. You can call it as a slider. Okay, and as the slider moves from one end to another, from left to right and right to left, the divider can vary the output voltage from maximum to the ground. Now let's build some simple circuit and then try to do some coding. So this is the circuit we are going to build with a simple LED, all right, and a current limiting resistor and our potentiometer connected to the analog pin. So basically we will use the potentiometer that controls the value at which the LED blinks. That is the code we are going to write, right? Okay, and the connection, of course, the one outer pin of the potentiometer is connected to the ground and the other external pin is connected to 5 volt of Arduino board, and the middle pin of the potentiometer is connected to the analog input pin, that is A2 of the board, right, of the UNO board. And the positive terminal, you can see as per the drawing of the LED, is connected in series to a 220 ohm resistor. You may also use 470 or 330 ohm, whichever place kind of gives you a bright light in the LED, you can use that resistor, right? And that is connected to your pin number 13, the digital pin 13 of the UNO board. And the negative terminal is connected to the ground, obviously. So the way we are going to structure this code is the analog input will basically turn the LED on and then off, which is then connected to pin number 13 of Arduino UNO board. The time delay, the delay function at which the LED is on and off depends on the value which is being gathered by your A2 pin, that is the analog read function. Okay, that is the analog read function. So we have here in this circuit, we have connected the potentiometer pot to the analog pin 2 of the variable UNO board. When the shaft is turned towards left, the amount of resistance on either side of the potentiometer changes, and the distance between the pin connected to 5 volt and the ground gives the analog input, right? So keep a note of this. We need input 0 when the shaft is turned in one direction, while we read input 1023 when the shaft is turned to the other direction. That is how the logic works. In between the turning input between 0 to 1023, we get the desired value returned by the analog read function. It is proportional to the voltage being applied to the pin. Now what we can do is we will write a quick code and I will show you how the logic is applied and it works. So let's keep rolling, guys. Let's open our Arduino IDE, and I am already in my IDE. So let's write some sketch here. Let's say int we need to set, let's define a name, say potentiometer pin. Okay, potentiometer pin equal to 2, that is your analog pin. So it select the input pin connected to the middle terminal of the potentiometer, and then let's say int LED pin like this equals to connected to pin number 13 and semicolon. It selects the LED pin. Now let's say int value, which we are going to read, value equals to 0, right? The value initialized to store the incoming value from the potentiometer sensor, right? So that is the value we are going to read. And then let's go to our void setup function with a 2 curvy braces, the brackets, and then open a curly bracket. Inside the curly bracket, we need to say pin mode like this. Pin mode, the happy little red orange color changes. And then in the pin mode, what we need to define is LED pin, comma, output like this. Okay. And a semicolon. The syntaxes are important, guys. Keep a note of it. So in this line of code, the pin mode LED pin, comma, output, the LED pin is declared as the output pin, right? That's what we are trying to do. Now come out of that block of the code. Let's define our void loop. Say void loop. Oops, all in caps. Void loop. Okay, like this. Open parenthesis and a close parenthesis. And then let's open a curly bracket. Inside the curly bracket, what we need to do, let's define the value of the potentiometer has to be read, and value equals to analog read function like this, analog read. And what we are going to read, we are going to read potentiometer pin. Let me just copy the same thing so that I don't do any spelling mistake. Potentiometer like this, potentiometer pin. And then so this basically reads the value from the potentiometer pin, right? And then what we need to do, digital write. We need to use the digital write function And what we need to write? We need to write the LED pin comma on, which is your high. Okay, so this will turn the LED pin on. Okay, and then we need to delay, use the delay function. Delay what? Guess you are not going to put a timer here. Oops, it's in uppercase. Delay. In delay, what we need to delay? We can delay the value instead of a timer. Say value. Value has been declared is equal to analog read in the initial, right? And in the int value is also already a 0. So value. So basically the delay time is in milliseconds. That's how it is. And then the delay value, after the delay value, digital write. And what we need to digital write? Here we need to write the LED pin comma off, which is low. Okay, here turn the LED pin off, and then we need to delay the value again. So delay the value. Okay, after delaying the value, let me scroll it down. Okay, so this basically will delay the time which depends on the value stored from the sensor. Alright guys, this seems to be okay to me. Let me just compile and try to run it. Let's compile the code. I hope, oops, there is a syntax error. So what is the syntax error here? Delay value, the LED pin. So there seems to be something we are missing here. Oh, okay. Alright, I missed the semicolon. So guys, we need to be careful, right? So if we miss the semicolon, it's going to throw the error. Let me compile again. Done compiling. Alright, let me just upload. I am uploading the code to my Arduino. Perfect, it's uploaded, and let's try to now change the value in the potentiometer and see what happens. I'll just share my video here. Right now I'm going to turn the potentiometer. Let's see what happens. It's in the lowest value. Let's change the, oh, there you go. Can you see that guys? The blinking of the LED. I hope you guys can see it pretty. It's too bright, right? Yes, now I am going to turn it right fully and see it reduces the blinking speed, slow and steady. So the variable resistance changes, and automatically the reading from A2 pin, it works as per the logic we gave in our C code. There you go. Now it's totally slow. It's to the max and the lowest. Now let me just rotate the potentiometer again. There you go. Can you see that guys? You can see how fast the LED is blinking as the value of the potentiometer changes. Perfect. So our code seems to be working and our circuit seems to be working, and of course our project seems to be working perfect, no doubt about it. Alright guys, so that's it for this lesson. I hope you understand the logic of using the potentiometer by using the analog read function, and how we are able to detect the sensor value from the potentiometer. So using the same logic, we will be using multiple sensors and read the external environment around us, and our Arduino is going to beautifully detect those environment, and we need to write the logic, send the output, and the output can be either on your terminal or on a LCD screen or remotely through a mobile. We can do loads of applications, which I am going to teach one by one in this series guys. Alright, do leave a comment below, and if you have any questions, will be happy to answer that. Do give me a thumbs up and a like. I'll be back soon in the next video. Bye bye.